Hello, good day viewers. Welcome to another additional mathematics presentation. So in this presentation, we are still answering questions from additional mathematics paper 1 for 2023 internal. And this was the last question, question 12. So this question is coming from secular measure. That's the topic. So the question reads, in the following diagram, ABC is a semicircle. So we have A, B, C. So this shape right here. So this is a semicircle with center O right here. The radius is 10 centimeter. So this is the radius from here to here, or from here to here, 10 centimeter. And the angle AOC, it's 1.87 rad. So meaning that the angle is in radians. AXD. So this part also is a sector, okay, with the center X. So the center of this sector AXD, it's X right here, and it has the radius of 16 centimeters. So the radius from here, to here, okay, 16. Again from here to here, 16. That's the radius. Okay, so let's look at our question. So here we have these questions now. So we have our question A. Find the area of sector AOC. So we come back to our diagram here. We need to find the area of the sector AOC, meaning that we are talking about this sector right here, this one. So how do we find the area of this sector? So to find the area of this sector is very easy. We are just going to use our simple formula. So this is question A. So just say area is equal to half, or 1 over 2 times r squared times theta. So this is the formula there. So area equal to half times, since we are finding the area of A or C, this sector right here. So the radius is C from A to O, which is a 10, or O to C, which is a 10. So this will be 10 squared times theta is the angle in radian for A or C, this angle right here, which is 1.876. So from here, we write area equal to, so just punch everything on the calculator there, see what you are going to get. Right, so this is our answer once we punch everything on the calculator, as you can see. So the answer that we have there, we have 93.8 centimeter square. So this is the area. So we have found question A. Let us now move on to question B. Alright, so now we have come to question B. We need to find the angle AXC. So we need to find the angle AXC. So let's look at our diagram right here. So we want to find the angle AXC, meaning that the angle which will be right here on X. So how do we find the angle on X? So to find the angle on X, there are just a few things that we must take note of. First thing, when you look at this angle which is right here, this angle is in radian, and this angle on O is along this straight line, okay? So we know that we can find an angle which is right here, because we know that angles on a straight line, they add up to 180. So to find the angle which will be here, okay, we can get the pi minus this angle which is right here. So that's the first thing. So we are now on question B. We are finding angle AXC. So first thing, we need to find this angle which will be right here, okay? We need to find that angle angle XOC. So angle XOC, the angle on O right here, we'll get pi minus 1.876. Okay, that's the first thing. So this will give us what? Let's calculate. Alright, so once you press on your calculator pi minus 1.876 radians, you get this angle. You get 1.26. So now we can round it off. 1.26. Again, this 5 will be a 6. So 1.266 rad. Remember, make your calculator to be in radians, okay? As you can see, mine is in radians here. Okay, so this is the angle we have gotten in radians. So this angle that we have gotten, okay? This angle that we have gotten is just for this part right here. It's just for this part, okay? It's just helping us. Now, we have noticed that the radius from A to O, it's 10. Even O to C, it's also a what? A 10 right here. That we know. It's a 10. So let's try to find now the side XC. But how do we find this side? Remember, I've been told that from A to X, it's 16. Now, A to O, it's a 10. So meaning that to make A to X, it will be a 16, of which O to X, we have to subtract 16 minus 10, which will be a 6. So O to X, we have a 6. So here there is a 6, here there is 10, and you want to find this side. I hope you are getting me. So let me just draw it so that you see what I'm talking about. So this is what we have, okay? So this is the shape. This is the triangle that we are talking about. So OX, so we have said here it's 6 centimeter. I hope you know where the 6 is coming from. We just said from A to X, it's 16. Then A to O, it's a 10. So to complete this distance from A to X, we just say to find OX, we'll subtract 16 minus 10, which will give us a 6 from O to X. Then here, it's a 10. Here, it's also a 10. Then here, we have an angle in radians, which is this angle that we found. Here, we have 1.266 rad. Okay. Now, I'm saying we need to find this side. Okay. CX. So how do we find CX? Alright, so now what we are going to do to find the distance CX. So this is capital letter O. Here we are going to have small letter O. Capital letter X. Here we are going to have small letter X. Capital letter C. Here we are going to have small letter C. So since we have two sides and an angle, and we need to find the third side, we are going to use the cosine rule. Okay, so this is how we are going to use the cosine rule. So we want to find this CX where there is O. So we are going to say O squared is equal to this O squared. So we are using C and X. So we are going to have C squared plus X squared minus 2CX. Okay, and then cos O, because we are using this angle. Remember, put your calculator in radians. Don't forget that. So we are going to have O squared equal to, so our C squared represented by a small letter C right here, which is a 6. So this is 6 squared. Our X, it's a 10 squared, as you can see, minus 2, 6. Then our X, it's a 10. Then cos, so where there is this angle, we are going to put this angle right here, which is 1.266. I hope this is clear. So from here, we are going to have O squared is equal to, just punch these on the calculator and write the value here. Okay. All right. So this is what you get. You'll get 99.988132, then 490, then 07. So remember, we are finding O, not O squared. So you need to introduce a square root, even here, a square root. Okay, so that this and this will cancel. We just remain with O equal to. So we just need to find the square root of this. Okay, so the square root we'll get of this is 9.999,406 6069. So since when you look at the length sides, they are correct to the nearest whole number. Okay, so even this one we can make it to the nearest whole number, which will just be O is equal to, so this will be a 10 centimeter. So we are finding CX. So this means that our CX is equal to 10 centimeters. So meaning that here it was a 10 centimeter. Now, what can you observe here? So what you can observe is that if OC is 10 centimeter, CX is also 10 centimeter. This tells us that we have an isosceles triangle where two sides are equal. So if the two sides are equal, it means that even the angles are equal. So this angle and the angle which will be right here, they are equal. Meaning that if here the angle is 1.26 radians, even here the angle will be 1.266 radians because of this property. This and this, they are equal. These two length sides are equal. So it's an isosceles what? Triangle. So here we are just going to say angle AXC is equal to 1.266 rad or radians. So that was our answer. Okay, I hope it's clear. So we can now move on. We go to the last question. Okay, we can now move on. So I hope you are able to see our last question here. The question says, find the area of the shaded region. So we want to find the area of the shaded region, the area of this shaded region. So to find the area of this shaded region, we are going to identify all the shapes that have been connected to this shaded region. So first thing, we can notice that we have this sector AXD, this bigger sector right here. Then we also have this smaller sector inside. We have AOC, this one right here. Then we also have OXC. This is a what? A triangle. So to find the area of this shaded part, we are going to find the sector of this of AXD. We are going to find the area of AXD, this sector, okay, minus the area of this sector AOC, this one right here, which will be added with the area of the triangle OXC. That's what we are going to do. So I do hope that it's clear there. So what are we going to do? We are now on the last question, which is question C. So we say area of shaded region is equal to. So I've said we are going to get the area of this sector AXD right here. So the formula will be half r squared theta minus. So now, since I said the area of this sector AOC to be added with the area of the triangle OXC. So say this area of this sector AOC, this is the formula also, half r squared theta plus the area of this triangle, which will be, because this is a non-right angle triangle, OX is a non-right angle triangle, so the formula that we use, it will be half AB, and then we say sine, we are going to use this angle right here, which we found for O. So we say sine O. I hope this part is clear, and then we close. So from here, let's just substitute the values. So we are going to say area equal to, so 1 over 2 times, so for this sector AXD, the radius from here to here, it's a 10. From here to here, it's it's a 16, this 16 right here. AX is a 16. So this will be 16 squared times, then what is the theta? Okay, what is the theta? Because we are saying AXD. So the theta that we have found this theta right here, this angle right here, which was what? 1.266. Okay, then minus 1 over 2 times this one, the radius for AOC. Okay, the radius is a 10. From A to O, it's a 10. So this will be 10 squared. Theta is this angle, which is 1.876 plus 1 over 2, this one, times. So since we are finding the area of this triangle OXC, so this will be, since we have these two sides, we had 6 here, then here there is a 10. This radius AO and OC, they are equal. So it's a 10 here also. So 10 and 6. So we'll get 10 times 6, then times sine. So now sine, what angle are we using? So the angle we are using is the angle that we found, which was right here, which is 1.266. So make sure that your calculator is in radians. Okay, so from here, area equal to, so I can punch these on the calculator. All right, so when we punch the first one for this one right here, this is what we are getting, 162.048. so we have 162.048 minus, now we can just punch for this one. We have this half times 10 squared times 1.876 plus half times 10 times 6 times sine 1.266. Remember, your calculator should be in radian. As you can see, mine here is in radian because these angles, this angle, this angle, this angle, they are all in radians. So let's punch this. All right, so once you punch these on the calculator, okay, you are going to get this value, 122.417.242.8337. So this is what I'll write here. So we have 122.417, then we have 242, then we have 8337. So from here, just say area of the shaded region. Okay, area of the shaded region is equal to, so just subtract this minus this and see what you are going to get. So once we punch on the calculator, we are getting this 39.630757166.3. So in our conclusion, you say area equal to, so we can just write it to three significant figures, which would be 39.6 square centimeter. So this is the area of the shaded what region. This is the area of the shaded region. So we have come to the end of our short presentation. Thank you so much, everybody, for having time to view this content. This has been your presenter, Mr. Mlenga. Bye-bye.